Hey guys, here's another video to help you with the concept of series. We're going to explore a very common type of series called the geometric series. Okay, the geometric series is basically a series where you have a term, and the next term that you're adding in is that same term times some particular r value. Okay, some sort of like a constant value. And the next term would be ar squared, because each time you're multiplying by r. So this is a times r, then this is times r would be ar squared, ar cubed, etc., until eventually you have your general, ar to the n minus 1. You have your general term here. Okay? Plus dot dot dot. Okay, so if n is 1, it's just a, right? This is basically r to the 0. This is at your n equals 2, you have r to the 1. N equals 3, you have r to the 2. So it's n minus 1 is your power of r. Okay, and this would be the basic structure of a geometric series. So if I write that in sigma notation form, just to make it a little easier, I have my a, r to the n minus 1, and of course a can't be 0. If a was just 0, you're just adding up a bunch of zeros. It's not very applicable here. Okay, so this is our geometric series structure. Sorry, this looks really bad. A, r to the n minus 1. That's that. Okay, let's take a look at this and say, all right, let's call that our sum. Right, our series is going to be our sum, which is a plus ar squared, etc. Okay, and let's multiply through by r. Okay, let's do a little bit of shenanigans here. Let's multiply both sides by r. Okay, if I do that, I'll get rsn equals ar plus ar squared plus ar cubed plus ar to the 4th plus dot 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 ar n minus 1 plus ar to the n. Okay, so let's look term by term. So I have ar squared, ar cubed, ar to the 4th, etc. Obviously I could write ar to the 5th. I'm going to have a term right in front of this one that's going to be ar to the n minus 1. And then I'm going to add in one more term. If I multiply this by r, I'm going to get r to the n minus 1 plus 1, which is ar to the n. Okay? So that's going to be my, if I multiply through by r. Let's subtract this series from this series. So, I'm sorry. This series, well, the original one. This was the original one, right? So I'm going to take my original series and subtract this series. So Sn minus Rsn. Okay. So if we subtract term by term, I have an a in this series, but I don't have an a over here. So a minus nothing, of course, is just a. My a to the r minus a to the r, that's gone, 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 etc. Gone. Okay. The only thing left is I have nothing minus ar to the n. So it's going to be minus ar to the n. So again, I started with my original geometric series. I multiplied through by r to create a new series, and I found the difference between the two. And the difference between the two, of course, the main terms are just carried through. But all these terms cancel out one by one, except for the first term here and the last term here. All right, let's clean that up just a little bit. I do want to solve for the sum. I'm trying to find the sum of this series. So this would be 1 minus r equals a minus ar to the n. Divide both sides by 1 minus r and clean it up. So this is going to be a 1 minus r to the n over 1 minus r. That's my sum. And then I'm thinking as n goes to infinity. As n goes to infinity, this doesn't really help me if n is going to infinity if r is any number bigger than 1. Okay, if r is like 5 or something, raising that to the nth power, I'm not going to be able to get this to cancel anything out. It's going to diverge. But if r is less than 1 or greater than negative 1, somewhere in between, sometimes they'll write that as the absolute value of r less than 1, then the limit as n goes to infinity for this would be 0. Okay, think about that. If you have, say it's a half, 1/2 to the n, that's 1 over 2 to the n. That goes to 0. So this sum actually becomes a over 1 minus r as long as the absolute value of r is less than 1. So the geometric series will converge when this happens. So the geometric series converges. And what does it converge to? This is your formula for it. Okay? The sum of a geometric series will be a, which is your first term, right? That was our first term, divided by 1 minus that constant rate, that value that we multiplied through by, as long as the absolute value of r is less than 1. Okay, let's see that work, and it'll be a lot easier. Let's look at that first example we did in the other video. I believe it was 1 over 2 to the n, right? That sequence looked like this: 1/2, 1/4, 1/8, 1/16, etc. Okay, and I want to find the sum of the series that uses this sequence. So my series would look like this, and I want to find that sum. So first things first, I want to identify, first of all, is the limit going to 0, which, well, we already discussed that last time, right? The limit as n goes to infinity of this is 0, so it passes that test right away. It's like a gateway test. If that doesn't work, we can't go any further. But then we also want to see, is it geometric? Well, look, to go from 1/2 to 1/4, we multiplied by a half, by a half, by a half, by a half. My r value is a half. Okay, 1/2 is less than 1. Okay, so I know my r value is okay. And how about my a value? Well, when n equals 1, my first term is 1/2. So according to my new rule, my sum should be a 1/2 over 1 minus that rate, the r value, which is right here, 1/2. 1/2 divided by 1/2 is 1. And that's what we got in the other video. Okay, we did another one in the other video. We did, what was it? Let's see. We had, it was 12 over -5 to the n. Now this one doesn't look as obvious, but we can make it look good. Okay, first of all, let's realize that the 12 doesn't really matter. Okay, that's 12, and the -1 to the n doesn't really matter, and look what's left. 1 over 5 to the n. Okay, I just broke it apart piece by piece. The 12 is just a constant. I'm alternating -1. This is basically -1 times 5, right? So -1 to the n times 5 to the n. So I pulled that out, and then I've got 1 over 5 to the n. Okay, and we talked about this, looking at if it's going to converge by taking the absolute value, and as n goes to infinity, this goes to 0, so that means this original one converges as well to 0, so that means it passes our gateway test, and now we can check to see how this fits into our geometric model. Okay, so we've got our first term was, let's see, -12 over 5. Okay, and my r value is going to be negative, or 1 over -5 really, to the n. Right, that's basically the same thing. Negative, right, this was -5 to the n, so -5 to the n, -1 to the n, 5 to the n, same thing. So my r value is going to be -1/5. So the absolute value of -1/5 is less than 1. So now I've got, my sum is going to be, slide that up a little bit, -12/5 divided by 1 minus -1/5. So -12/5 divided by, that's 1 plus a fifth, that's 6/5, which is -12 over 6, which is -2, which is what we got in the first video. Okay, so this is sort of a special case when it's geometric. If it's not geometric, we'll have other tricks we can use, but if it is geometric, this will get you the sum, and as long as the r value, the absolute value, is less than 1, this will converge. Okay, if you want, you can take a look at a couple of those beginning problems again from the book, like last time, and see if you can see if they're geometric or not. Okay, let me know if you have any questions, and I will talk to you guys later. See ya. Oh, wait a sec. Hopefully you didn't stop yet. I just realized that I pulled out a negative here, which wasn't in the original, so this would actually be to the n minus 1, right? let's just check that. If n is 1, this becomes negative 12 fifths times 1, okay? And if n was 2, now I'm back on track. I've got my negative here, which is positive, and now I go back to alternating. Okay, so I didn't change anything here. I still had the right r value, I still had the right a value. But in general, and it caught my eye because in general, this is what they usually will look like. A r to the n minus 1. That's the general form for our geometric series. Now, it doesn't actually have to be that. It just shifts where your a value is going to be if you don't have it in this form. Okay? All right. Sorry about that. Let me know if you need any more clarification, and I'll help out. Okay. See ya.